Okay, so we started off this chapter with scatter plots, and all those scatter plots that we did on that first day were all linear scatter plots. Okay, but this chapter is all about quadratics, so we're going to see the difference between the two. All right, so go ahead and break out your graphing calculator. We are going to type in this new information. So we are given this data right here. It says a recent study compared the speed in miles per hour and the average fuel economy for cars. The results are shown in the table. So basically, if you drive your car that fast, you're going to get that many miles per gallon. All right, so it's actually fairly interesting data, at least to someone who pays for their gas. So hit the stat button, go to edit. You are typing in that information. Go. Okay, so once we've typed in that data, a reminder, if you haven't done it yet, you got to make sure you turn your diagnostic on. Did you do that the other day, Aaron? Okay. So your diagnostic has to be on. If you are, you're good. Okay. If you hit the y equals button, remember plot 1 needs to be turned on. If you've done something else since the last time we graphed, you got to turn plot 1 on. Let's go to zoom. What zoom are we going to do here? Zoom 9, because zoom 9 is zoom stat, and it's going to zoom into my statistical data. There are my dots. Okay. On Monday, we did linear. Is this a linear graph? No, it's very much not linear. Okay. That is a curved line. So we're going to find out the equation of that line. So let's hit stat. We're going to go over to calculate. On Monday, we did number 4. Number 4 is linear regression line. Okay. It's in the form mx plus b. That is not what we want to do today because that is not a line. Which one do you think we should do instead? Quadratic regression. So we're going to go down to number 5, a quadratic regression, because that looks very much like a parabola. I'm going to hit enter on quadratic regression. It's got L1, L2. We're going to go down to store regression equation. Remember, we want to store that line. That way it graphs it for us. So here we go alpha and then F4. So up here on the trace button. And then we're going to select Y1. Okay, so it's going to save us Y1 right there. We're going to go down to calculate that thing. There is my equation. Okay, that is the equation of a line. It's kind of annoying to write down, but let's write it down because it did ask us to do that. Okay, it said write down your equation. So notice that it's in the form ax squared plus bx plus c. It's in standard form. So it's going to be y equals negative 0.008 x squared. We go 3 decimals. Okay. On this one, you might want to go an extra couple if you were doing it just because of so many zeros there in front. But negative 0.008, then 0.746 x, and then plus 13.472. There's my line. Let's just look at that line because we want to see what it looks like. So if you've stored it as y1, now when I hit the graph button, it's going to draw that parabola through my data. How does that look? Pretty good, right? You would say that that's a good representation of our data. I forgot to kind of look at this a second ago. Let me go back to this part. Notice the other thing that's stated here is my r squared value. My r squared value is 0.96. What does that mean if it's 0.96? Very strong. Remember, the closer we are to 1, the better our graph is going to be, the more accurate it's going to be. 0.96, you could tell that pretty much from this. You're really close to those dots. It's a good representation of our model. All right. So we've got our model. Part B says use our model to determine how fast a car should be driven in order to maximize fuel economy. Okay, this is a graph of fuel economy. On the bottom, it's speed, but on the line itself is fuel economy. Where would I look to find the maximum of this thing? The vertex. So you could do 2 things. You could do negative b over 2a, but it was weird decimals, and I already got it saved in my calculator, so I might as well use my calculator. All right, so what I'm going to do is I'm going to go second, calculate. Which one of those do you think I'm going to find? The maximum. So let's go down to number 4, maximum. I'm going to move my cursor. This is where I think the peak is, like right in here. But I'm going to move to the left a little bit just to make sure I'm to the left. I hit enter. I go to the right a little bit for right bound. I hit enter. It says guess. I hit enter a 3rd time. There is my answer. We're going to 3 decimals. So the question was at how fast should the car be driven? looking at that answer, how fast should the car be driven? 45. That's how fast it should be. What would your miles per gallon be? That's the 30.440. Okay, but how fast should you drive? 45.499 miles per hour. So very similar to what we did before. The only difference was we used a quadratic regression. Because our data was quadratic, it made way more sense to do a quadratic regression than a linear. Questions on the first part? All right, let's do the second part. Solve the inequality. 2x squared is less than or equal to x plus 10. Okay, so I want to show you a picture of this first because I feel like my first period class, when I didn't show them a picture, they struggled a little bit. So I'm going to try to show you a picture. So it is 2x is less than or equal to x plus 10. Is that the correct? Is that right? Oh, okay, that's why that looks super awful. 2x squared. All right, there we go. So it's this big, tall parabola. Oh my gosh, look how high that thing goes. Whee. I feel like something's weird there, but yeah, here's what we care about. Oh my gosh, go zoom in. There's the graph that we're kind of care about more. It goes super up there, but that's what we're looking at, okay? That's what we're trying to solve here, and we'll come back to that graph here in a second. Okay, 2x squared is less than or equal to x plus 10. We need to solve this thing, okay? This is a quadratic. It's got an x squared term. It's got an x term. Anytime we're trying to solve a quadratic, what do we have to do? Set it equal to 0. Right now, it's not equal to 0. I need to set it equal to 0. All right, so the first thing I'm going to do is move the x over and move the 10 over. So I get 2x squared minus x minus 10 is less than or equal to 0. So I moved everything over because anytime I solve an inequality or a quadratic, something with an x squared and an x, I need it to be equal to 0. Now we're going to solve. How can we solve a quadratic? Completing the square, sure. If you want to do that, go for it. I'm not doing that. Factoring is the other one, or quadratic formula. Those are your three options. Complete the square, factoring, or quadratics. I'm going to try to factor if I can. Okay, if you don't want to do that, you could do quadratic formula. Go for it. All right, the difference here is there is a number in front. There's a 2, and some students are great at this, some students aren't. If you already know how to do it, then do it. Okay, I'm going to show you how I do it because I hate factoring when A is not 1. I hate guess and check because to me, math class should be, here's how you do this problem, and you're just going to solve it the right way every time. It bothers me. So I'm going to show you my method. Okay, this is called borrow and payback. So we're going to take whatever number is in front, my A value in front, and we are going to multiply it to our constant. All right, so this problem becomes this: x squared minus x minus 20. Once I've done that, then I'm going to just factor like normal. So I'm looking for two numbers that multiply together to get me 20, and they add to get negative 1, negative 5, and positive 4. We factored like normal, then the last thing I have to do is pay back. So we borrowed the 2. You can't just randomly borrow the 2 without paying it back in the end. Or in other words, we're going to divide by 2. So we're taking both of those numbers and dividing by 2. We get x minus 5 halves. I can't really reduce that at all. It's 2.5 if you'd like to call it 2.5. That's fine. Great. And then this one is going to be x plus 2. We are factoring and solving, so the last thing we need to do is take those two terms and set them equal to 0 and solve. So this one is going to be x is equal to 5 halves, and this one is going to be x is equal to negative 2. Did anybody do just normal factoring without listening to me? Did you get the same answers in the end? You get 5 halves and negative 2. Both work. Whatever makes you happiest. If you already know how to do guess and check, don't listen to me. Okay, but if you've always kind of struggled with it, borrow and payback's a good method. Don't forget to pay it back. Students always remember the borrow part, and they forget the payback. All right, so that's not my answer yet because it was inequality. Okay, I want to write my answer in interval notation. All right, so the best way for me to understand what's going on is to visualize a picture of this thing. Okay, here's this graph right here. So let's go back to this graph. That thing right there needs to be less than or equal to 0. I know where it crosses the x-axis. It crosses the x-axis at 5 halves, so 1, 2.5, and negative 2. Which way is this parabola going to open, up or down? It was 2x squared minus x minus 10. Is it opening up or down? Up. My a value is positive, so it's going to open up. So my graph looks something like that. I want to be less than or equal to 0. So based on that graph, when am I less than or equal to 0? On the outsides of my zeros or on the inside of my zeros? That's an awful way of describing that. The inside was the awful answer to my awful question. But this part right here, would you agree that this is when I am less than or equal to 0? That graph is below that line at that point. And so my answer here is going to be -2, because that's where that intercept is, to this intercept, which is 5/2. It's in between those two. From -2 to 5/2 is when I am less than or equal to 0. Am I going to use brackets or parentheses there? Brackets, because it was equal to. That is my answer to this problem. Okay, that is listen to me, this is the number one missed thing on our next test. Okay, last year, this is the thing that students struggle with because they refuse to draw the picture. You got to draw a picture to understand what your graph looks like. Okay, we graphed the big crazy thing at the beginning, but notice what our answer was. It was between -2 and 5/2, like we thought, and we're including those answers because we were equal to that. All right, so the key, again, we looked at our quadratic, we made it equal to 0. We solved it like normal. And then we went back to, all right, what did our picture look like? Where is it less than 0? And I marked those spots. Let's try one more. Okay, a ball is thrown vertically upward with an initial velocity of 80 feet per second. The distance s in feet of the ball from the ground after t seconds is given by this equation. So this distance right here, s of t is the height, t is time. So you're taking the ball, you're throwing it up in the air. At what time will the ball strike the ground? Talk with your neighbor for a second. Come up with a way to answer that question right there. At what time will the ball strike the ground? Go. We want to know at what time does it strike the ground. Lydia, what did you guys discuss to try to decide when it's going to strike the ground? So my first class said that too, and we could do that. So finding a vertex, finding that maximum and understanding that concept, that works. But you could do this. Ready? Here's my ball. I'm going to throw it up in the air. Tell me when it hits the ground. Ready? Right there. That's when it hit the ground. What was the height when it hit the ground? 0. Well, this is an equation that tells me height, where s of t is the height. What do I want the height to be? 0. That's when it hits the ground. So all we have to do here is take this equation and make it equal to 0. You could do some stuff with the vertex on this problem in particular. That's not always going to be true because you don't always throw the ball from the ground. In this problem, we are thrown from the ground. That's what makes this work. Just be careful with that. All right. So we're just going to take the equation, set it equal to 0. We're going to solve now. This is a quadratic. We do want to make it equal to 0. What could I do to solve this thing? Factor. Good answer. Good answer. Factor it. What do both of these things have in common? A t? Yes. They have a t. Anything else? 8 you could pull out. That's fine. You could also pull out 16. Let's say we just saw an 8. Let's just act like we saw an 8 because I don't always remember that 80 is divisible by 16. That's not something I memorized. But I'd pull out an 8t. If I took an 8t out of 80t, what would I have left over? 10 minus 2t. That's factored. Is it factored perfectly? No, but it doesn't really matter. All right. All we are trying to do is not make it a not t squared problem anymore. It was a quadratic, but by factoring the t out, it's not a quadratic anymore. We're taking this thing, setting it equal to 0. So each part, I'm going to set equal to 0. And I'm going to solve. When is 8t equal to 0? Well, when t equals 0. So in other words, we threw the ball from the ground because at 0 seconds, the ball was on the ground because the height was 0. Then we're going to solve this other guy. So we're going to add 2t and then divide by 2. T equals 5. So this ball hits the ground again at 5 seconds. So that is the answer. When do I hit the ground? At 5 seconds. Kind of makes sense on what we did there. Set the height equal to 0. Just know, what did they give you And what are you looking for? Oh, that was a height equation. So take the height and set it equal to 0. All right, so there's the first part. The second one says, for what time is the ball more than 96 feet off the ground? So a little bit strange. But at what time are we more than 96 feet off the ground? So this is my height equation. I want to be more than 96 feet above the ground. So what do you think I should do with it? You could do that. I could write an inequality. What would my inequality look like? Greater than or equal to, or just greater than? Just greater than 96, because I want to be greater than 96 feet from the ground. I forgot my t, sorry. 80t minus 16t squared. All right, so there's my setup. I want to solve that thing. So if I'm solving a quadratic, the first thing I got to do is set it equal to 0. I need to move that 96, so it's going to be, I'm going to rewrite it in a good form. Negative 16t squared plus 80t minus 96 is greater than 0. Cool, I'm solving that. The one thing I hate about that is you got some pretty big numbers in there that I don't really want to mess with. How could I make everything a little bit better?
16.
Yeah, there's 16 in everything. In fact, I'm going to divide everything by a negative 16. Since everything is divisible by negative 16, I'm going to just make everything easier here and divide it by negative 16. So this is going to become t squared minus 5t plus 6. I made a mistake here. What mistake did I make as I did that? I divided by a negative 16. So if I divided by a negative 16, I need to make that less than 0 now. Okay, be careful there. Finish that problem. So you're trying to solve this inequality. So you somehow need to solve that thing and figure out on what interval am I less than 0. Talk with your neighbor, get it solved. We want to solve that thing. I know I don't give you a bunch of time. I'm a bad teacher. We're trying to solve this thing. We want to do what here, Kate? You factored it. Great. So let's factor. What two things are going to multiply to get 6 and add to get negative 5? Wonderful. T minus 3, T minus 2. Those are my two setups. Okay, they add to get negative 5, multiply to get 6. So we're going to get T equals 3 and 2. That is not the answer to the question. It was an inequality. Okay, so the best way to think of this is thinking, all right, what does this look like? All right, so I'm going to draw a quick picture of that. You can do other ways of doing this, but I think visualizing the answer is going to help you out significantly. All right, so I'm going to go to 2 and 3. So here's 2, here's 3. This is the thing I'm looking at because I can visualize that better. Which way is that parabola opening, up or down? Up. It is opening up, so my parabola is looking like this. I want to know when I'm less than 0. So my less than 0 is less than less than 2, or before 2 or after 2? When am I less than 0? After 2. From 2 until when? From 2 until 3. Again, I know I'm asking that an awful way, but from 2 to 3, in between those two dots, is when I'm less than 0. You got to pay attention. Am I less than 0 there or greater than? So my answer here is from 2 to 3. It's an interval. Am I going to use brackets or parentheses? Parentheses, because I am just less than and not less than or equal to. Questions on something there? Aaron, you good?
Yes.
You sure? You're giving me the funky eyes.
Well, I'm trying to see whether you, like, how do you know whether it's inside or outside of the curve?
Because I'm trying to be less than 0. Okay? And so when I'm less than 0, that is the function, the equation. When am I less than 0? When is my y value less than 0? Okay? And so think about this parabola. Right here, I'm less than 0 because I'm below the x-axis.
Why do we shade above the x-axis?
It was that time interval. I may have shaded incorrectly. Or I may have shaded weird, but I was shading in from 2 to 3. It wasn't necessarily that I was below it. Sure, you can shade right here, but I was more of from the time from 2 to 3, I was below the x-axis. My shading was a little strange. Good clarification there.